Good afternoon everyone. Today we are going to discuss effect of superheat on mean temperature of heat addition. So first of all we need to understand two things here. What is that? Superheat and mean temperature of heat addition. So see, what is superheat? Superheat is a phenomena by which we are heating the steam before going to turbine. See, you can see 1, 2, 3 and 4. It's ideal Rankine cycle. So what the change we are doing, this is the point where steam is going to enter the turbine. But what we are doing, we are using a device, superheater, where after this, what the superheater will do, it will heat the steam to more temperature. So the point 1 will shift to point 1 dash. So our new Rankine cycle will be 1 dash, 2 dash, 3 and 4. Now, you understood what is superheat? Mean temperature of heat addition already I have explained in the last video. It's the hypothetical temperature on which we are adding the heat. See, heat addition is from 4 to 1 or no, from 4 to 1 dash. So it's an isobaric process. So mean temperature of heat addition is the hypothetical or assumed temperature somewhere here where we are adding heat, in which we are adding heat. Okay. So the new improved cycle after using superheater or superheat process is 1 dash, 2 dash, 3 and 4. Now, why we are doing superheat? Superheat is done to increase the mean temperature of heat addition. You can see here 4 to 1. Okay, there is an infinite temperature difference in heat addition process. This is Q1. Okay, so there is an infinite temperature difference from 4 to 1. Now what we are doing, if you increase this point from 1 to 1 dash by using a superheater, your mean temperature of heat addition, which is Tm, this is Tm, this will increase. See, you can easily see here what 4 and 1. Okay, this is there will be a mean temperature between point 1 to 4, but now the mean temperature between point 1 dash to 4 will be more than the mean temperature between point 1 to 4. Okay, so by using a superheater or by using the process of superheat, our mean temperature of heat addition will increase, and by increasing the mean temperature of heat addition, we mean that efficiency of cycle will increase. Why? Because efficiency is function of Tm only. Okay, so the question arises, till where you can increase superheat it, or till where this point 1 can go. Suppose 1 dash, where you will go above. So this depends on the metallurgical limit or metallurgical condition of the turbine, because this is the inlet of turbine. Suppose the melting point of the materials which we are using in turbine is 1800 degrees Celsius. Okay, and after superheating you are getting temperature 2100 degrees Celsius. Then what will happen? You know, material will get distorted or melt. So this has to be limited. So see, I am heating till T max. So this is the maximum temperature till where you can superheat it, or depends on metallurgical condition of the turbine. Now how to increase the efficiency of turbine? T max is fixed here depending on metallurgical consideration of the turbine. Okay, so now what is the method to increase the mean temperature of heat addition or efficiency of turbine? Okay, so you can see here, if you increase the pressure, heat addition in which you are adding heat, that process pressure, this is P1, and now you are adding heat at some pressure which is more than P1. See here, so I am drawing here like this. Okay, like this, and this line will come like this. Okay, so now see, 4 has shifted to 4 dash. Okay, and after that you name here 5, this point, and this point is as 6. Now the next method by which we can increase mean temperature of heat addition is that, see, this is initially 4 to 1 dash was our constant pressure heat addition. Okay, so now what, it was on pressure P1. Now you are adding heat at pressure P2, in which P2 is more than P1. So if the isobaric process or constant pressure in which you are adding heat, that is increased, So you can see here, see 4 has shifted to 4 dash. So now 1 dash and 4. See here, 1 dash and 4 mean temperature, and now 4 dash to 5. So from 5 to 4 dash, P2, constant pressure heat addition at P2. In this heat addition, mean temperature is more than 1 dash and 4, which is at pressure P1. So by increasing the pressure, you can increase the mean temperature of heat addition, which means you can increase the efficiency. So what is the limit in which you can increase the pressure? Will you remain increasing it like this? No, it has some limit. How we got a limit of temperature? See, as soon as if you increase the pressure, this line, isentropic line of turbine is going to shift left side, this side, okay? So if the isentropic line is going to shift left side, it means what? It means moisture content in the steam is going to increase. It means water content in the steam is going to increase, and if water content will increase, it is going to erode the turbine in the later stage. Okay, so see, initially point was 2 dash, okay, then by increasing the pressure, this point has shifted to 6.6, okay. So at this point, water content is more in the turbine, okay, steam, so it will erode the blade. So we have to fix this thing. One thing more you should know, that 0.85, the drainage fraction at the exit of turbine should not be less than 0.85, otherwise it will damage the turbine. Okay, so now we have increased the temperature, superheat we have done, we have increased the pressure, working pressure. Now its limit. Now as soon as if you have increased the pressure, you can see here this line has shifted this side, and it will damage the turbine blade. Now to improve this quality, we see drainage fraction or quality, we use reheat cycle.